who's going to take some notes for us. All right, so I'm going to ask that question again in a few minutes. Please think about it. The blue sheets are going around. Please keep those moving. Try to get it signed.
Al, which note well did you use?
The right one, I hope. I think I got that fixed last time. At least last time I didn't get the same comment. So we'll find out in a few moments.
Okay.
There was a question about the note well from Scott. All right. Okay, I see 9 o'clock. So let's get started. This is the benchmarking methodology working group. I'm Al Morton, one of the co-chairs of the group. Sarah Banks, the other co-chair, was unable to join us this time, but she will join us remotely at a couple of junctures. Okay, great. Thank you, Joel. Our AD advisor is Joel Yeagley right up front here. Joel's going to be monitoring the Jabber room. Marius is going to be taking notes. I still need one more note taker because Marius has a long presentation and I need somebody to put up their hand and be helpful. And I still need someone to put up their hand.
Sarah has put up her hand.
Okay, that's great. That's great. That will be a big help. Thank you, Sarah. Okay, so this is a small room, but it's always better if you move closer to the front. Here's the note well. Now it's early in the week. This is the right one according to Mr. Bradner. So we've got the right start here. Anything you say in the meeting at the microphone, and when you speak at the microphone, please give us your name first, very clearly. That will help the minute takers. And if you show the minute takers your badge, at least the local one, that will help too. But anything said at the microphone is a contribution in the IETF. It's subject to our rules. If you have IPR, you must disclose it promptly. And you must be familiar with all these RFCs here, the best current practices on IPR for our organization. Any questions about that? Okay, so everybody's clear on IPR. Here's our agenda with a little modification as we go along. We're doing number 1 and 1B here, the charter and the milestones and status. Data center benchmarking will not be presented by Lucian. It will be presented by me. It turns out both the co-authors are flying right now. so neither one of them could join us remotely despite our best efforts. So I'll do that one.
Flying here or tangentially?
Flying tangentially to New York and Berlin, if I remember correctly. Ramke, could you help us with notes today a little bit? That would be fantastic. Thank you. Thank you so much. So we've got 2 note takers now because I twisted an arm. Excellent. Let's go. All right. Then Marius will be speaking about the IPv6 transition benchmarking. I'll be back to talk about my individual draft on, or now working group draft on VNF and infrastructure benchmarking. Benchmarking for SDN controllers. You get a trend here. There's a lot of benchmarking going on. That will be covered by Bhuvan. And then we have that's all the work items. Then we have some individual proposals. Miriam Tahan from Intel in Ireland will try to join us remotely, and she'll give the talk on the vSwitch benchmarking draft from the OPNFV. We have benchmarking for control plane policing. And that's a brand new draft. We're hearing about the first time from Shishio Toshiya. Is that close enough? Good. Thank you, Toshiya. So Shishio will do that. Then we're back into the virtual world. We'll have a presentation on behalf of the authors, benchmarking high availability of the network function virtualization from Taeho Kang. And then we finally reach Robert Szabo's presentation. Is that correct pronunciation, Robert?
Yeah.
Okay. So Robert will tell us about virtual VNF benchmarking as a service. Interesting. And this is kind of a teaser for a longer talk that'll take place at the Network Function Research Group tomorrow, part of the IRTM. And then in the last 15 minutes of our meeting, we're going to recognize and celebrate that we've been in business here for 25 years, doing some pretty cool stuff. And the fact that the room is still full is also very cool. So let's any abashes to the agenda? Okay. Where is the blue sheet right now? Okay, so anyone who hasn't signed the blue sheet, like this gentleman right here who just came in, pass it back there, Ramki. That would be great. And let's get everybody's signatures on the blue sheet so that we don't get an even smaller room next time. All right. So yes, we talked about Jabber, IPR, and blue sheets. All right, that covers that. So here's the quick working group status. We still need to sort out the BGP data plane approved draft for this missing reference. And that's going to take some emails and some slight modifications to that draft to do that. But we need some follow-up on that with the authors. So now a quick celebration. The traffic management benchmarking has been approved. It's RFC 7640. Hooray for that. And shortly after that, we picked up another RFC on in-service software upgrade, and that's 7654. So lots of progress in the last interim period. Very good. So now we have some new working group drafts. They've been adopted on the data center benchmarking, the virtual. Looks like there's a typo in that one. Virtual VNF and NFVI benchmarking there. And right. So actually that should be, oh yeah. So we have drafts on those. And then the working group adopted 2 new drafts, and that's on the SDN controller benchmarking and also IPv6 transition. So there's plenty of work that we've got in progress here. We finished up a few things, great, but let's dive right into the next ones and get our comments and reviews going. And lots of new work proposals that I've already mentioned, so keep those proposals coming. We need to mark done on a couple of milestones. Last time we celebrated the 7501 and 7502 on SIP device benchmarking. Need to mark those on the milestones done. And for those of you joining the meeting for the first time, please put up your hands. Great, thank you for joining us. You'll find this is a welcoming community. It's easy to join. If you've got some test expertise, you'll fit right in. And this is a supplementary page, which gives you a little background information on joining the group. The best thing to do is dive in by reading some drafts and reading some email and putting comments on the list. So you can download this from the meeting materials. Okay, so here's our milestones. We're a little bit behind on IPv6 neighbor discovery, about a year. August 2005 was when our considerations draft on IESG VNF benchmarking considerations on that was supposed to be to IESG review. A little bit behind on that. We're not behind yet on data center, and we need to add milestones for the new things that we have adopted. So I'll be talking to the authors there to try to sort that out, get some dates for that, and we'll be submitting those milestones. All right. So when you're preparing a draft in the benchmarking methodology working group, very often the security people take a look at it at some point, and they don't read our charter. They don't realize that what we're doing is laboratory only work. And so this paragraph, modified for specific circumstances, has often helped the security director reviewer from flipping out and going, what do you mean you're going to do this on the internet? Well, we're not. We're doing it in an isolated test environment, and that's what works for us. So I put this up every time. And this is a summary of the work proposals that we have in progress. A few of these have moved off recently because we have adopted 2 drafts on IPv6 and SDN controllers. So now we're looking at, there was a vSwitch proposal, there's an OPNFV vSwitch benchmarking proposal, control plane, and high availability. I've got those all on the list here. And so that's the current summary. All right, so let me see what else we got. So you have to see the online agenda for related documents, some other stuff that hasn't been seen in a while, and that's the chair slides. So I made it through in 10 minutes. Any questions about that? Everybody's completely satisfied, and all right, excellent. All right, so let's go back to the agenda. All right, so next is the data center benchmarking draft, which I'm responsible for telling you about today. So I'll quickly find that. I think this is it right here. Oh, I think I've actually got it up already. Yeah, to try to save some fooling around. Okay, full screen mode. All right. So, as I said, Lucian and Jacob were unable to join us this time. They have these newly adopted drafts, and one of them is missing something here. It's missing the IETF after draft. So that would be useful to fix. But basically, these are drafts about adding on to the additional work of the classic benchmarking, specifically for data center use. So this is actually a slide which quotes our minutes from the last meeting. And the point here is that they wanted, Scott's comment was basically how to report on repeatability of measurements. These are the other things that we have discussed there, an error from the average and so forth. There's other possibilities. I believe the authors think that they've addressed this, but we'll see. And we also had some feedback on jitter. I looked at that, and it looks like it incorporated more of Scott's comment about this, the inter-packet being useful for measuring the burstiness of traffic, than it did my comment that led to Scott's comment, which was about I-1541 packet delay variation, the delay histogram, so to speak. So and the range of delays that are possible. So what I'm going to do is suggest some text for this particular section, and I'll put that on the list to help the authors. That will be as a participant. So we'll argue it all together as participants. Also, section 6.1, they've updated the buffer size, stating the larger buffer is not equivalent and can cause buffer bloat, so forth. And so they believe that all list feedback was incorporated, including Scott's comment about readability. And is that it? I think that is. So as I said, I've got comments, additional comments on the draft, and I believe, Scott, you do too.
Yeah, I've got quite a few, some sort of what the hell's going on kind of comments, and some actual let's think about it comments.
Okay.
So on the introduction, it would be helpful to be concrete. What specific devices are being given, a list of example devices that this is going to be being used on. Just what are we talking about here? Because the data center is a very fuzzy place with a lot of stuff.
True.
A more basic, let's think about it type question is really for this group to think about. What is the purpose of these tests for example, latency? To me, latency is, so what will be the impact if I stick a box in the path? That seems to be a logical thing. If it is that, then it is not first in to first out. I mean, it's not first in to last out, it's first in to first out. So it's what is the chunk of time which is added by sticking this box in there. So if that is the case, then you really do want first in to first out as the latency measure rather than first in to first out, last out, which is really the packet length determiner.
Right.
Which is not the processing delay, it's it's really a different thing. And that's our question for the group to think about, but my personal feeling is that it's first in, first out. If you are doing first in to first out, now that was section 2, section 2, the latency. Then for section 3.3 under jitter, there's a very complicated thing in here about, packet size and all kinds of crap, where if it's first in, first out, latency, the jitter is trivial because it's just when the first bit shows up. The variability of when the first bit shows up. It's not dependent on packet size. It's a much simpler thing.
Okay.
So that's section 3.3. Under section 4, I did a little homework here. So under section 4, it has all of these things of what type of device used to generate the traffic and measure the traffic, and type of line cards and traffic generator and transceivers and all that kind of stuff. All that's, I find it interesting to know all of that, but what difference does it make to the testing? If it makes a difference to the testing, then it should be stated as to why it makes a difference to the testing. And if it doesn't make a difference to the testing, it certainly shouldn't be mandatory. We're testing black boxes with black boxes. I'm not sure what value this has to the ability to understand the test, the results of the test. If it does, then it should be. Line rate. All kinds of stuff in here about line rate, but it doesn't answer the specific question. Line rate could be bits per second or it could be frames per second. It should simply state, this is section 5. So it should simply state that we're talking about bits per second or frames per second. Now, the implication by what this is it's frames per second, but it doesn't really directly state that. And then when it does go down to talk about frames per second, it forgets the interframe gap. So the actual frame per second calculation is wrong. But it's also a long thing in here about parts per million of frequencies, stability and all of that. And boy, that seems like overkill. If this thing is 0.0005% faster than that thing, what the hell difference does it make? We're not dealing with that kind of fine granularity. So this whole thing in section 5.2 about the fine granularity of the accuracy of the transmit clock, I just don't think that seems to be much overkill. 5.3 is where the interframe gap's missing. Under 6, what is this section? This section is on the buffering. I did see, maybe I just missed it, but I didn't see where it talks separately about shared and dedicated buffers. It's an awful lot of devices that have one big shared buffer pool, and all of the interfaces use the same buffer pool. So if one interface is using a lot, the other ones don't get as much. And it doesn't talk about that in here, at least wise I didn't see it. So
I think you've mentioned that before too.
Yeah. And then under incast, my basic question is, what are you trying to find out? This is the number of simultaneous packets coming in. What's the purpose of the test? And what difference is it going to make when you have the answer? Doesn't mean there isn't one. I just don't understand what it might be.
What section is that, Scott?
That is section 6.1, I think. It's part of the buffering one of 6.1, and it's particularly incast. 6.2 is incast, okay. So it's incast. And then under throughput, it talks here about good put, in particular good put, section 7, it's good put. and it's ambiguous. It's talking about the payload. Now, it would be more straightforward to say it's the IP packet minus the IP header, or it's the TCP packet minus the IP and TCP header. It's just ambiguous as to when you say payload, what do you mean by payload? Payload of the IP packet is the TCP packet plus whatever's on it. The payload of the TCP packet is what's on TCP. So just ambiguity here.
Yeah.
And what I don't understand on good put in general is how is this affected by the device being tested? Device being tested is a transit device. It's the sender and the receiver that determine the amount of payload per packet.
Yeah.
Not the device being tested. So I don't understand what the purpose of what the implication on the device under test is for this. If it's only for traffic that's being originated by the device or synced by the device, then maybe it would make a difference. But if it's just transit, which goes back to the what devices are we talking about thing that I said first. And then under I guess this is still under good put. It talks about good put measure. In addition, this is in section 7.5. Talks about differences include what TCP stack, OS versions, NIC firmware, and model. And I don't really understand what all those are about in terms of how that impacts the device being tested.
It sounds like, just guessing for the authors here, it sounds like they were intending to do some TCP-based testing, which, yeah.
All right,
so we'll see how
it's not clear what's going on there.
Yeah.
And that's what I have for comments.
Well, Scott, thanks for that excellent review, and I'm thanking you on behalf of the authors. I'll work with them to get this stuff incorporated. Truly appreciate it. Marius, please.
Okay, this is Marius Georgescu. I'm sorry, I should have typed all of that, but I'll look.
I scribbled it.
Okay, no,
but I'll bet you've got some.
listen to the flow, and then yeah, I'll not take it. I just had like a quite short comment about repeatability. Essentially, they talk about variation. I think they should be talking about variance because it has to account for the number of test trials. So it's I think that's important here. So they're just talking about mean and max and average, and I think there should mean and max don't hurt in a report, but I think variance is also important.
Good.
And yeah, there was the whole discussion about average versus median. I'm gonna try to have it as a work group discussion in my presentation, so we can talk about that later. Yeah, that's it. Thank you.
Great. Yeah, it's important to sort this through. Any other comments on this draft? Excellent feedback today. This is the kind of stuff we're looking for to make our work better and for all of us to learn a bit as we go along. So thank you, Scott. Thank you, Marius. And let's get those things in the notes and on the list. One or the other, both would be best. All right. All right, so I'm dropping that one. And now let's see, where do we go next here? Here we're on the agenda. Oh, Marius is up now with IPv6 transition benchmarking. All right. Okay. Just take me a moment to find this, Marius. In fact, you've got the bigger version over there. It's this one, right?
Yeah.
All right. All right, full screen. Okay, so let's figure about 15 minutes for this. I see you've got a lot of slides.
I'll try to wrap it up in 15 minutes. Okay, good morning, everyone. My name is Marius Georgescu. I'm from Nara Institute of Science and Technology. I'll be talking to you today about the draft. I'm the first author of benchmarking methodology for IPv6 transition technologies. I'm going to give a bit of about the background of why we're working on this. So essentially, I guess most of the people here already know about IPv6 protocol, and also the fact that it's not backwards compatible, and that kind of forced us into talking about transition technologies. And the internet also is undergoing a period through which both protocols coexist, and it's gonna be a while, I think, since we have around 5% now for worldwide use of IPv6. Next slide out, please. So essentially, we have our, okay, we already have a
Can you go back to the slide?
Yep.
That drawing is pretty amazing.
Thank you. It's not as it says here. I actually asked the author to the permission to use this drawing. It's pretty cool.
The amount of joy on those characters is just stunning.
Yeah, the drawing is called "Not Speaking," and I think it's pretty speaking about how the transition is kind of going right now. So the scared and little V6 is like, okay. So and patched up. I have to, yeah. The patched up was the really the part that I really liked about the. It is a bit patched up.
I like this one too, by the way.
Thank you very much. This also was, it's not like entirely my contribution. This was inspired by IETF95 presentation, which in turn was inspired by something else, but I just, yeah, I cited only that. So the idea is we have a lot of diversity in terms of IPv6 transition technologies. It started simply with tunnels and translation. It kind of evolved according to the use case, and now we have, in 2015, we have a couple. We have this is not all of it, by the way. There are more, and some of them are experimental, so some of them are not used. So RFC2544 is kind of IP agnostic, so it could test potentially IPv6 as well. RFC5180 is dedicated to IPv6 because there are some differences between IPv4 and IPv6, and one of them is extension headers, and that was mostly about that. Now, both of them do not take into account transition technologies, and when I'm saying transition technologies, I'm especially referring to translation and encapsulation. This brings some overhead to the process, and this overhead has to be accounted for, and this is what we are trying to do with this draft. Essentially, this is the scope of this draft. Yeah, let's go to the next slide now. So I'm going to give a brief overview of the draft. So essentially, since we have so much diversity in terms of transition technologies, we first would need to classify them somehow, because also we might have future developments of these technologies, and this will help with the test setup, with the common set of traits that the technologies have. So we propose the classification, and we have some associated test setups according to that classification. Also, there's some calculation formula for taking into account the maximum frame rate with the frame size overhead, because there is some frame size overhead from the translation or encapsulation process. Now we also try to include the tentative metrics for benchmarking scalability, and particularly load scalability. So how much load can a device gracefully take without losing performance? So we are trying to quantify that by looking at the performance degradation under the stress of multiple network flows. Also, since some of the transition technologies are stateful, that is, they're managing some sort of state table. How well they're managing that state table is important to account for in their performance. So we have specifically proposed for stateful IPv6 transition technologies some benchmark proposed in RFC 3511. Also, there was a comment in IETF91 from Neilini. Thank you very much. We finally have a proposal for that. We don't know how well it is. Professor Lence, who contributed this text, worked a lot in DNS6 benchmarking, and we are looking to get feedback on this. So yeah, next slide out, please. Okay, so in terms of history of this draft and some outlook, I don't know much. I'm a sort of a newcomer. I started in IETF91, so I don't know exactly which milestones we're talking about, but I know about the working group last call, so that's what I thought was one of the next milestones for this draft. So the draft was proposed in 91, as I said, in IETF 91 and not 99. It evolved, hopefully, with the feedback from the working group to, well, individual draft 01. And there was a call for adoption last meeting. It went well. And thank you very much for your support and your comments. And now we have version 00 of the adopted draft, and there's a detailed change log if you want to take a look at it. Like all the changes, we tried to address most of the comments. We didn't address all of them, but yeah, most of them we tried to address somehow. So we need feedback about how well we did that. So please take a look. And I'm thinking for working group last call, if the progress is good enough, if the working group agrees, we are hoping IETF 96 or 97. Remains to be discussed. Okay, next slide, please. So now about the update overview. So we redefined the generic categories of transition technologies after we received some feedback from Fred Baker about it. Removed Sonnet, it seems not to be of interest anymore, so we removed it as example media, and we're stopping at Ethernet. We also recommended a fixed, and when I'm saying fixed, it's not exactly fixed. MTU size, and that's the minimum IPv6 MTU plus then encapsulation and translation overhead depending on the transition technology, because I think that's the fairest way to do it. Also updated the text a bit about extension headers. There's not much information about that, even in the drafts that, well, discuss the transition technology. So I'm not sure exactly how we should approach that. Clarify the limitation of the dual device under test setup as Scott was recommending. Proposed some benchmarking tests for DNS resolution performance and added some rationale about using mean instead of median. Well, in the meantime, I kind of started to change my mind, and maybe median makes more sense. I want this to be discussed in the working group, if possible. And yeah, there are other various smaller editorial changes you can check in the detailed change log. Next slide, please, Al. Okay, so the generic categories would be single translation. That means we have a domain A and a core domain. The core domain is assumed to be IPv specific, and then IPv6, IPvX. I'm trying to make it generic. So X and Y are either 4 or 6. And it doesn't matter like it should be either from 6 to 4 or from 4 to 6. Are translated to IPv at the edge between domain A and the core domain. Now, dual stack is not actually in the scope because it can be easily tested. Like the devices can be separately tested with either recommendations from RFC 544 and RFC 5180. Then we have encapsulation. So in this context, we have, it's essentially islands trying to communicate to an IP specific core. So they're either encapsulated or they're double translated. That's about the 3 and 4 categories. So if you have questions about that, I'll clarify later. In the meantime, let's
what were the categories before Fred's comment?
So it was, I called them a bit differently. I call single stack, dual stack, encapsulation based and translation based. And I think this one, at least for Fred, it makes more sense. He said so in the mailing list. I had another discussion with him. He said, okay, this looks more reasonable, and I'm perfectly fine with it. I don't care about the naming as long as the people understand what I'm talking about.
Well, the names are important. They have to convey what you're trying to do.
Yeah. I understand that they essentially kind of mean the same thing. It's in terms of domains instead of looking at customer edges and provider, like customer and provider model. So. Okay, now for the fixed MTU, we had a comment from Masataka Mawatari, the author of the 464XLAT as a transition technology, and he was suggesting a fixed MTU, and he suggested use the minimum IPv6 MTU, and I said, okay, but like when we have encapsulation, I don't think it would be fair to encapsulation to be tested with the same fixed MTU as translation. So I said, okay, let's account for with the translation or encapsulation overhead. That's my idea. If there are, well, I don't know, problems with that, we can of course change that. That's my proposal. Okay, next slide, please. In terms of extension headers, so for example, RFC 6145, which discusses IP-ICMP translation, doesn't say clearly if they say it's not support, aside from the fragmentation header, they don't support extension headers. That's what it's written in the RFC. I don't want to get into the discussion of what's supported or not. I wanted to put it as a note that test traffic, I want to encourage testing with extension headers, and it can work with encapsulation. I haven't tested myself that. I'm planning to do it, but in principle, it should work. Now, in terms of translation, most of them do not support it because there's, I think it might be impossible to do that. So essentially, I would like to keep this note that, okay, testing traffic with extension header might not be possible for transition technologies which employ translation. And maybe I should add some transition technologies, stateful transition technologies that employ encapsulation as well. Maybe that could be a good addition. Well, after I wrote the part, this occurred to me. So if everyone agrees, this is our proposal.
We've got about 3 minutes, including questions.
Okay, so yeah, let's move on. Then let's keep all the limitations. I tried as much as possible to explain that there's an inability to reflect asymmetry. So for this, okay, we should test with a single DUT setup as well. In this context, for encapsulation transition technologies, okay, we have comments.
Yes.
Please.
Hi, Paul Emmerich. I have a comment about latency.
Yes.
The way you're defining it, you would only need to do 20 measurements of latency, which I think is a problem if you consider modern software devices, because you often get a really bad tail latency, and you should really look at the 99th percentile or 95th percentile, because especially if you're running something in a VM or something, then you get some packets which are way slower and you wouldn't capture this. It can be really annoying if 1% of the packets are slow and the test doesn't capture us.
Okay, I'm sorry, what was the question?
It's about latency.
Yeah, I understand it's about latency.
It's a
comment.
Yeah.
Okay. Okay, thank you for your comment.
Ramki Krishnan, Dell. So there is also an implementation dependency, I guess, on whether this function is implemented as a physical function or virtual function, especially since we're working in the virtualization space. We should consider that.
Yeah, thank you. We would like to stay away from the virtualized world, especially since there are ongoing efforts to standardize testing for virtual capable technology. So I think physical is the way to go for now in terms of testing transition technology. So that's just my opinion.
So let's say for the scope, you haven't mentioned virtualization.
Yes, I should mention clearly then.
Let's start out in the physical world, and then perhaps there's a BIS version of this where we can look at the virtualized side. And it may be that we don't need that.
It might be too complicated. That's my problem. We still don't have anything published about testing virtual in a virtual environment. So that's my worry.
Sure. I mean, the reason I brought this up was since we're already working on it, so there's kind of a correlation. All these functions are already virtualized or implementations.
Maybe I can say, okay, if there is a virtualized function there, the recommendations are in that draft. Would that work?
Or maybe I don't know. What will be the best way to capture this? Is it separate work item, or at this point, or the virtualization? I mean, basically the virtualized implementation.
Right now, the scope of the draft is the physical. It doesn't mention virtual. So let's discuss that further on the list.
Okay, right. Sounds good.
Thank you for the suggestion. Yeah.
I'm going to cut the mics at Scott so this is the last comment.
Then this is a non-content comment,
Okay.
but a document comment. You list a number of terms which you then say use the definition in 2544 or whatever.
Yeah.
Just list them. Just say the following
sure.
terms are defined and should be used as defined in the other RFC.
Okay.
So don't have separate segments for them all. Just list them.
Yeah.
Okay. Thank you.
Simplify it.
Yeah.
Thank you very much.
Good.
Okay. Sorry, I took too long. So
Do you
I'll.
want me to rush? Well, you know, you prepare really beautiful decks of slides. You can see exactly where you are according to the top here.
Yeah.
You know,
We
along
still
the
have some
outline.
more, but I mean.
These are really fantastic. But I'm
there's.
I'm cutting to the end here.
Yeah. Thank you.
All right. So next
We can
step-
take it to the mailing list. So please read the draft if you're interested and tell me. We hope for more comments.
Yeah, and I think the comments you got were covered very well. And,
Okay, thank you.
So you know, thank you for this.
Thank you very much, Al.
I really want to learn more about this template.
Okay. Okay. Thank you.
All right. Okay. So I'm up next. All right, let's see. Oh, boy. Oh, here it is. Okay. All right. So now, gotta do this. Okay. So we've had this considerations draft now for a year and a half. It became a working group item recently, and this is the 01 version of that draft. Progressing along, plenty of comments along the way. Here's what we did in version 01. We've addressed Romkey's comments on power. Romkey, you suggested a standard there that could be used for measurements. That was good. It was a message on the list, which I've taken care of. A gentleman named Saurabh Chattopadhyay made a comment on VNF resources, which we addressed in section 3.4. And you can, I will highlight for folks that you can go to the differenced version of the draft and very easily see exactly what changed. This is one of the tools we've got in the IETF that make tracking these things very easy. And Marius, you had several comments on the list, and I've responded to all of these on the list as well. So we've taken care of these in the various sections mentioned. And then at the last meeting, we really had quite a few comments again. Miriam Tahan asked about the VNF footprint and the auxiliary metrics, like, for example, CPU utilization and so forth. We've handled that in several sections in the draft now, mentioning that that these auxiliary metrics don't actually fit in the matrix. That's a kind of a follow-on comment here at the end of the page. And then verification processes is a topic that's come up in a number of ways. For example, if you've deployed a VNF and it's only a patched version, let's say a security patch or a small bug fix, and you want to run some verifications of this online while you're actually using it to serve some customer traffic, that the amount of active traffic or whatever it is that you're using there can affect it. And incidentally, Romkey, this was Romkey's comment, and we're kind of embracing this in a new work item in ETSI NFV now. So come back. All right, Scott.
Scott Bragner, I mentioned this to you before, but it's more convenient if you put the changes since last version at the end of a draft rather than at the beginning.
Right.
It reads a little bit better.
Yeah.
And having separate sections for each version change is much more helpful.
I'll do that in the future. So here's what I think we've got for the next steps. But I wanted to highlight the charter here for a moment. This very first item on the slide is kind of a restatement of our charter. The VNF and related infrastructure benchmarking. We've reliably characterized physical devices here. This work item extends and enhances the methods to virtual network functions and their unique supporting infrastructure. And then it says, a first deliverable from this activity will be a document that considers the new benchmarking space. to ensure that common issues are recognized from the start using background materials from industry and SDOs. And the milestone for this, as I mentioned, was August this year. So this draft is actually it's actually working out differently. This draft is the one that's being referenced by the other SDOs. And so I'd like to propose, as an author now, not as a co-chair, I'd like to propose that we go to a working group last call. And so now, returning to my working group chair hat, I will simply ask the question, are there any objections to going to working group last call for this draft? I see some shaking of heads and no one getting up to the microphone objecting. So it's really up to Sarah, my co-chair, to call sort of the consensus and whether this draft is ready for a working group last call. I'll let her do that. And if you see a working group last call come on to the mailing list, which is where it has to take place anyway, please participate. Let's get a last look at this. And then if it's ready, let's get it published and pushed to Joel for further work. Joel raises a thumbs up hand. Okay.
Sarah has a question, which is how many people have read the draft?
How many people have read the draft? So I see 1, 2, 3, 4, 5, 6 hands in the room, and that's about a third of the room. So just touching on that, Sarah. Yeah, I've really got lots of good feedback, and everybody whose name is in the acknowledgements obviously has provided something significant. So thank you to you all.
There are many people who have read the draft and not here.
Yes, Ramki points out that many people who've read the draft are not here. So as I said, the names are generally listed. So I'm going to try to recover some time here, and we'll see what happens based on the co-chair's calling of the situation. Thank you. All right. Okay, so now I think we've reached the last working group item, which is benchmarking for SDN controller performance. And that's going to be presented by Bhuvan as soon as I find your slides, Bhuvan. And if I remember correctly, you wanted me to find the PowerPoint versions, right? Why don't you just walk up right there and point to it? Okay, it's this one, right? Yeah. Okay. Well, that's actually very helpful because my screen gets incredibly small when I get connected up to that thing. All right, here we go. Let's push this thing up, and let's go to presentation mode. And Sarah's going to help out with this. Roughly 15 minutes for the presentation.
Okay, sure. I'll try to wrap it up. Hi, good morning. I'm Bhuvan. I would like to quickly give an update on the progress of the draft SDN controller performance benchmarking in this session. A quick highlight about this draft is that I have presented this draft in SDNRG group yesterday, and I think some of the participants here also were in the session yesterday. And based on the interactions I had with them, it looks like the draft is in right direction. Of course, there are some comments that which we need to take into account. So before getting into the updates, I'd like to give a quick background about this draft. I hope this is for the benefit of people who have not read this draft. So the objective of this draft is to define a generic set of metrics and methodologies to assess and evaluate the controller performance independent of its protocol support. So the key, yes, Scott, you have something.
Finish your introduction.
So, yeah, okay. So this enables to benchmark the controller for performance, scalability, reliability, and security. This also provides a standard mechanism to assess and compare the performance of controller of various controllers implementation. So this is about the objective of this work. Next slide.
Okay.
So this list history how the draft has been evolved over a period of time. So now next. So now this draft has been adopted just before this meeting. Thank you everyone for your support, comments, and feedback for this draft. And yeah.
Okay.
So next is the test setup. So we have defined two test setups in this draft. So one, to test the controller working in a standalone mode. So I think there was a comment from Scott on IETF92 about lack of clarity in the test setup. So what is DUT and what is tester? So I hope we have clarified that in the latest revision. So next slide, please. And this is a test setup where this tests the controller working in a cluster mode. So primarily when we want to support redundancy and load balancing, of course, cluster mode is more useful. So that way, this is another setup we have defined in the draft.
Okay. I had a quick comment there. I know that the Open Daylight folks have the concept of a sort of a leader and a follower within clusters. I wonder if that's something we need to learn more about and to reflect in this aspect of the work.
I think the leader and follower, what I understood, since we also working with ODL, so that per se, it's only to elect who is the master, who is the slave. So whoever first terms as a master, I mean the leader, so he decides, I mean from there the election process starts. That's what our understanding about the working of clustering in the ODL.
Okay, okay.
So Scott Bradner, this slide's actually a good one to talk about, or the previous one, either one.
Okay.
You're testing things and reporting on results of the time it takes for a controller to do things. The
Yes.
things that it does involve asking the network element to do something and report back that it's done. I think you probably need to have some text in there that specifically talks about the fact that the forwarding plane test emulator has to be very repeatable.
Okay.
And that if indeed it is going to vary as to its performance relative to the number of nodes it simulates and things like that, those have to be taken into account in reporting the results.
Okay. Okay.
Because it's not the timing you get out of it is the controller plus the node.
Right.
And
Yes.
when you get two variables in the same result, it tends to be confusing.
Right.
So you might want to think about how to talk about that.
I think this is a valid comment, Scott. Certainly will take this into account and capture that as part of the draft. Thank you.
I've heard the same thing, Scott, that it's hard to separate these two, and your solution is perfect. Make one of them repeatable.
Right. Thank you.
Sorry, Marius, a quick comment. Like I didn't have time in my presentation, but we should have a solution for average versus median. We should discuss it somehow, and I'll start the discussion on the mailing list maybe.
Yeah.
To have some, I don't know, hint for. I think this applied to all the drafts. That's why I'm.
Of course, of course. Yeah.
Certainly, I think this is a valid point. Even we also received a couple of comments that the average outliers some of the values that we are observing. I think certainly, yeah, since last meeting also we couldn't conclude. I think average is what we wanted to move on. And I think we need to also propose other ways to capture the results. Yes, I agree with you. Certainly, I think we can take on to the mailing list and discuss further. Yes. Yeah, next. So this is a quick overview about the benchmarking test that we have defined. So there are 8 metrics defined under performance. Probably I may skip going through them unless you want to. Is it okay?
Just give everybody a moment to take a quick look and read it.
Yeah, so the 8 metrics. So the first one is the topology discovery time. So primarily measures the time that the controller takes to discover a given network topology. And next one is the asynchronous message processing time. So measures the time that the controller takes to process a request from the SDN node, and also the rate, how many such requests the controller can process. Next one is the reactive path provisioning time. Basically measures the time that the controller takes to set up a path from a source to destination when the request been received through the southbound interface. Yes.
Scott Bradner again. Can you pop back a slide or two? Yeah, there. You might want to consider putting these 2 diagrams or the set of diagrams in the terminology document.
Oh, okay.
In addition, or maybe only there and referring, maybe probably both.
Okay.
Because to understand the terminology, you really have to understand this,
Okay.
much more so than with many other systems.
Okay. Okay. Yeah, that makes sense. Thank you.
Does anybody see a particular metric here they'd like to ask about? All right, let's move on.
And from the scalability side, so there are 3 metrics we have defined. So one to measure the maximum number of sessions that the controller can handle, and the next one is network discovery size. So it measures the maximum number of nodes that the controller can discover. And also the last one is the forwarding table capacity. It measures how many entries that the controller can learn and then maintain in its forwarding table. Yes, Scott.
Scott Bradner again. The discovery and that sort of thing is very dependent on the ability of the test environment to be emulating multiple nodes. And so again, it's the combination of scaling of the test of the controller and the scaling of the device that's emulating what the controller is controlling. And I think that you're going to find that latter is going to be very difficult. If you're up in the thousands of nodes, the emulator is going to be pretty hairy.
Yes, here it's most likely a semi-emulated model is what, yeah, probably currently that particular point is missing since we say it's emulation. But again, it depends on the test solution, since whatever test solution that we have currently is able to scale up to 10,000 node. So even on a software environment, since running on a CARDS hardware, since now if you look at the CARDS hardware is coming up with 32 cores, which has so much capabilities. So I don't see really a constraint putting up on there. Yes.
I'm not sure whether it's a constraint or not, but maybe you want to consider ways to test the tester, which doesn't involve a particular device under test, but there's some way to actually be testing your emulator.
A calibration.
To see whether indeed it can scale to the point you think it can.
Okay, okay. Yeah. Thanks.
This is Jinru from China Mobile. I have a questions about the definition of the control session capacity. I see in this context we have defined a session which is maybe an open flow session, but I want to say that for the IETF controller we do not have the one kind of session, because the IETF controller often offers some multiple protocol capacities, such as we have a netconf protocol, we have open flow protocols, and from the perspective of the protocol, open flow session is different from the netconf session. And if you can support 100 different open flow session, which means that you can support 100 number of netconf session. So is there any necessary to make some classification or the different differences between different sessions or different scenarios? Okay.
Yeah, to answer your question, so I think that's what we said, we are independent of the protocols that we support.
Yeah.
So of course, yes, without the protocol, you cannot test it. You may enable one of the protocols in the southbound, be it OpenFlow, be it Forces, be it I2RS, whatever it may be.
Okay.
So what we recommend is whichever protocol that you use, so measure the controller's capacity with that protocol and report those metrics as part of your test reporting. So the test reporting captures those parameters like what southbound protocol you use, what northbound protocol you use, and how much with that protocol, so how much the controller scales up. So those are all the parameters that we are capturing, recommended to capture as part of test reporting.
Right. Okay. And a version and so forth. Yeah, that's essential.
Doug Montgomery, just so back maybe related to Scott's comment. So when you're trying to measure something like discovering topology, do you have all the time measurements strictly defined by events on the southbound interface, not what's going on in the network? Or maybe another way of phrasing the question is, could you envision factoring out the latency of the network or the emulated network itself? and have the amount of time the controller spent processing topology discovery messages?
Yes, so we assume the emulator, which is almost a standardized element. So that is what we recommend. That is key for every test, right? So any traffic generator that generates or emulates an element. So we assume, this is an assumption, that the emulator as not, I'll not claim it's zero. Obviously, there could be a slight impact in the emulation.
But in the case of
thing.
something like LLDP topology discovery,
Yes.
a lot of that time is switch to switch, and it has nothing to do with the interface at which you're actually testing.
Yes. So this was our assumption. So the whatever components or elements being emulated by the emulator is almost like it's a kind of a standard elements. That's what we assume. So yes, of course, that's a valid point. So if we should make sure that that's repeatable and it is common across various measurement. Maybe it shouldn't have a variable behavior across the test. Maybe it should be common. That can be one thing which we can look at it. But as such, testing an emulator, I don't think it is really needed. No, probably this is again a question. So how to address?
Scott Bradner again. I very much like what he just said. Consider strongly that that the reported results should have subtracted out the time it takes for the emulated nodes to do their function.
Okay.
And keep it to just the controller's action.
I think I understand this pretty well. I'll try to help you with this, Bhuvan.
And
yeah,
and sorry, and one other thing which I just recollect is, to an extent, all the metrics that we are measuring. Maybe you can go to the previous slide. Maybe, I think it is mostly addressed, except for some of the tests. Maybe to the test setup, please.
Oh, to the test setup. Okay. Yeah, sorry. Okay.
So to an extent, what we try to do is we'll try to measure everything at this juncture. So that way, I think except one or two traffic tests, probably that will have an impact on the lower layers. But most of the tests, whatever we are measuring, is being measured at the ingress point of the emulation, and even both on the control plane and the management plane. So that way, to an extent, we avoid the delays within the lower layers. Maybe still one question that you asked about the topology discovery time, the switching of the elements between the switches emulated in the emulation plane. Obviously, that is still a question which we need to capture it a little more. The characteristics either as part of reporting, or we'll have to highlight it somewhere. I think that is one still to be addressed. But I think most of the test is being captured, results being captured at that juncture to avoid certain delays.
Scott Bradner again, can you be clear to document that? That's what you're saying.
Yeah.
Because I think that's a very important point that he made.
Yeah.
Yes. Yeah. So we also have a section that talks about test recommendation. I mean, test measurement recommendation. So where it clarifies it, probably we can, if something being missed there, probably we can further add that.
Just to be clear, I'm talking about the reporting.
Okay. Okay.
So when you say how to report it, you want to make sure that it says that the time it takes for the emulated node to perform its function is subtracted.
Okay.
Is not part of what is being reported as the performance of the SDN.
Okay. Okay. That's perfect. Yeah. Thank you.
Okay. So let's wrap it up.
Yes. So yes, the changes highlight. So there was a big discussion about the definition of the controller, what is a controller and what not in the mailing list. So thanks all for your suggestions. So I think we have clarified that as part of the scope. So from the perspective of this memo, the SDN controller we define as a function that controls and manages the SDN nodes and SDN capable infrastructure devices, and any device that doesn't have the control plane functionality are not considered part of this benchmarking memo. So that's being clarified. And further, there's some editorial comments. And as a next step, so there are the feedback from the SCNRG group as well as over here also, that to align some of the terms defined in the terminologies to the RFCs already in the IETF and IRTF streams. So I think that's our immediate next step, to align with that, to get the industries in a common page. So that's one thing. And besides that, I think there are a lot of useful comments given to us in this forum by Scott and others. So certainly, I think that's very useful. We'll take it up and then address in the next version.
Yes. Yeah. Thanks for the good comment.
Regarding the
make sure the note takers have your names if it was difficult.
Yeah.
All right. Thank you, Bhuvan.
Yeah.
Excellent work. Excellent presentation yesterday too at SDN Research Group. And let's keep going on this. I think Sarah maybe wanted to add something. Is Sarah able to be heard?
Or mirrored.
She says, no, Bhuvan did well, thank you.
Okay, excellent.
Okay.
Well, you've heard that from all of us now.
Thank you. Thank you very much.
All right. So that that concludes the working group items. And now we're going to hear, hopefully, from Miriam Tahan on the vSwitch benchmarking and OPNFV. Let me see if I can get that slide deck up. And I think this is it. Let's go to this one. Every time it does this. Miriam, can you speak and be heard?
Good morning, everyone. Can you hear me?
Yeah.
Yes, now we can. Excellent. This is the first time this has really worked for us. We've cobbled together Skype calls before to make this work, Miriam. It sounds like we're in a lot better shape here now. That's great. Please go ahead. I've got your title slide up.
Yeah, excellent. Thank you very much, Al. Good morning, everyone. My name is Miriam Tahan. I'm a software engineer in Intel, and I'm also the VSPerf project lead in OPNFV. Today, I'm going to be giving an update on the draft title, Benchmarking Virtual Switches in OPNFV. The purpose or the objective of this draft is to inform this working group of work in progress within a testing project in OPNFV that's based on its extensive literature. Okay, I think we can go to the next slide there, Al, please.
And I'll give you 15 minutes for this, Miriam.
Okay, no time pressure at all. Okay, so today we're going to have a quick look at some of the updates that have been happening since IETF 93. We're going to talk a little bit about VSPerf in practice, some planned future work, and then a summary for this working group. We can probably go to the next slide, please.
Okay, we're there.
Okay, excellent. So there have been a few updates to the test specification itself within VSPerf. We've been looking at adding some new tests to extend the matrix coverage, and I'll cover that in the next slide in a little bit more detail. We've adapted the feedback to migrate the SOAP test terminology or naming from using RFC 2544 throughput now to refer to RFC 2889 maximum forwarding rate, as that value or that metric is measured in line rather than subsequent to packet transmission being stopped. We've also worked on refining the fully meshed RFC 2889 tests to include two things. The first is the deployment scenario, and we'll delve into those in a little bit more detail lately, and also to report the number of ports used for each of those tests. And we've also adapted or extended our scalability tests to look at situations where flows are not installed on the switch at all versus the situation where flows are pre-installed on the switch. Next slide, please, Al. So if people recall, this this is the 3x3 matrix that's adopted from the considerations for benchmarking virtual network functions and their infrastructure draft that Al spoke about just a few moments ago. We extended it to include a scalability column. And as we can see, we've been working on extending our coverage across this matrix. All of our new tests are highlighted in white. So we've renamed some of the tests from throughput RFC 2889 address learning rate, for example, to activation to the activation category or naming. We've also modified, as you can see, the max forwarding rate tests under speed of operation. We've extended that category to include a new test called CPU RFC 2544 zero packet loss, which measures the CPU utilization as well as the CPU utilization in flight for an RFC 2544 zero packet loss tests. We've also been looking at reliability in a little bit more detail. Our SOAK tests have been renamed, as we can see, as I mentioned earlier on, from RFC 2544 to RFC 2889, and they also include the max packet forwarding rate naming as well. And we've added some scalability tests as well to enable us to conduct some new tests based on those definitions there. So we're still missing the activation tests. We haven't really looked at those, but they're on our list of tests to add in the future as we continue to expand on this matrix itself. We can probably go to the next slide, please, Al.
Right. Okay. And, pardon? No, you can jump up now if you've got something quick, Marius.
One clarification, just one clarification question. I don't see any, I couldn't find any definition for SOAK. I know instinctively what it means, but maybe it should be clarified.
Yeah, we can do
just
that.
my thought.
It's a long-term test, so a SOAK test, yeah, traditionally in the industry. Yeah, we can make that clear someplace. Good.
Excellent.
We got one more comment.
Any Ramki Krishnan Dell, any reason for tying this specifically to OPNFV? Because the it is all about vSwitch, right? So it's very generic.
Well, it's tied to OPNFV because it's a project in OPNFV,
okay,
working on the vSwitch benchmarking, and it's also tool development there. So that's a part of it that Miriam's trying to get to.
Oh, okay, got
right.
it. Yeah, thanks.
Cool.
All right, so we're on the slide after the 3x4 matrix, Miriam.
Yeah, excellent. So within the LTD and the test spec, we've actually adopted a number of deployment scenarios. The first we can see on the far left-hand side is what we call phi-to-phi, where packets are simply forwarded from the testing device through the vSwitch and received again at the testing device. Excuse me, the picture gets then a little bit more complex as we move from left to right. So in the middle, we add a VM into the picture, and this deployment scenario is what we call PVP. And as we move further right, we actually end up, adding another VM into the picture, and ultimately, hopefully, we scale this out as a separate test as well, where we keep adding and adding VMs and characterizing performance of the vSwitch as we add more and more VMs. But in the case of the 2 VM scenario here, the deployment itself is called PVVP. So we can probably skip on to the next slide.
Okay.
Please. Yeah. So one in particular that one particular deployment scenario that we mentioned within the LTD and the draft is VM to VM, but we don't actually talk about it in enough detail. So this is something that we do need to dive into a little bit more, and there's an opportunity to work with some folks that were looking at another draft called benchmarking methodology for virtualization network performance, in particular to focus on this VM to VM scenario, as well as one way from the tester to a VM and one way from a VM all the way down to a tester. And I'll talk about this in a little bit more detail in practice shortly. And then the last deployment scenario we have is VM to VM, but over an overlay network. So what does VS-Perf in practice look like? I think we can go to the next slide there, Al. As I mentioned, you know, brace yourself, benchmarking is coming. We can definitely skip on to the next slide. Yeah, perfect. So in practice, what we're actually doing is we're taking each one of the tests that we define in the test specification and implementing them within a Python-based test framework in VS-Perf. So we use the test framework essentially to prove out and refine the tests that we have defined, as well as the methodologies for each of those tests. So as of today, we're actually able to conduct, you know, there's a snapshot of the listed tests that we can do on both stock OVS and OVS with DPDK. So we can do things like simple RFC 2544 packet loss ratio tests, back-to-back. We can measure back-to-back frames. Each of the tests are based on different deployment scenarios. You can see the deployment scenario pre-appends the name of the tests, funny enough, except for back-to-back, which is probably something I need to look at. We support the 3 deployment scenarios that I mentioned at the very, very start: FI2FI, PVP, and PVVP. So we can probably just skip on to the next slide from here. I'm very wary of time. Yeah, so that's just a review of the deployment scenarios that are supported today. If we skip on one more.
Okay.
The actual tests that are covered within the framework today are highlighted in white within the table here. So we can see that they're all based within the speed of operation category. But we will be starting to look at RFC 2889 within the next dev period. So that's actually that's an error in the slides. Sorry about that. And again, as I mentioned, they're supported for FI2FI, PVP, and PVVP for vanilla OVS and OVS with DPDK. Next slide, please, Al. So VM to VM in practice, we actually haven't really implemented VM to VM because we've actually had a lot of concerns around time synchronization between virtual machines and clock accuracy in terms of using them as source and sinks for traffic. So we're actually, we've received a recommendation which is under consideration at the moment, excuse me, which is to include an external tester or hardware traffic generator to act as the source and the sink. So you connect to your VM through some sort of bypass technology from your test device, and traffic simply then gets forwarded through your logical ports attached to each of the VMs and back out to your test device again. So we can probably keep going to the next slide, please, Al.
Okay.
So in terms of future work, we're continuing to expand our features in terms of what we support for both virtual switches and testers. Currently, only Ixia is supported. We've actually only had our initial patches for Spirent merged this week, so we're hoping to have them supported as a tester and traffic generator shortly. We're also looking at some software traffic generators as well, like MoonGen, and then there's another hardware traffic generator which also uses a virtual tester called Xena that we're looking at integrating with VS-Perf. In terms of methodology extensions, there are things that we need to look at, such as iterations for the RFC 2544 short trial tests. So anything that's not a soak test, we need to really think about how many iterations we need to conduct for a test before we're happy to take the result as an average across those trials and iterations. That's to be tried and tested out, I think, unless there's any suggestions from the working group. So we'll continue to prove out and refine the methodology and tests throughout the framework, and then we have plans to add more tests to the LTD and the framework itself. So these vary from scalability tests to overlay networking tests, all the way to the deactivation tests that I spoke about earlier. And I won't run through each one of these because it'll take up a lot of time. But if anybody has any ideas for any other tests or anything we should be taking into consideration, do let me or Al know.
I'll quick.
Yeah.
Right, and I'll quickly mention, Miriam, that the two MoonGen developers are here in the room with us.
Oh, excellent.
And they took a picture of this. But we're hoping that in some way they'll be able to join us a little more completely. Apparently, it was a little weird that MoonGen got brought to our attention by someone who wasn't on the development team, it seems. So we'll have to sort this out. But the MoonGen developers, Paul and Sebastian, you're very welcome to join us in this work.
Excellent.
And they're nodding. So good. Well, there's a gentleman at the microphone, Miriam, with a question.
Sure.
Hi, Doug Montgomery of NIST. So I guess it's a sort of an expansion of the question about the title, whether it's specific to OPNFV. I was wondering, is it specific to software-only virtual switches?
So
I mean, it seems like a lot. Go ahead.
No, finish your question. Go ahead.
Oh, well, it would seem to me that the majority of the core of this might be data plane benchmarking for SDN switches, period. Whether that's a pure software switch, a hybrid software switch with some hardware assist, or a hardware switch. And so I'm kind of wondering, I mean, I guess I understand that's in the context of the OPNFV project, but from the IETF's perspective, why isn't there a draft on benchmarking methodology for SDN data plane? And then this would be potentially a small delta on top of that. So
it would be great if it came in that direction, but it didn't. And I think it's partly because, Doug, that this project intends to automate all this testing. And so the part of the test tool that Miriam's probably going to tell us a little bit more about is actually starting the vSwitch, making scripting the external test devices, basically getting the whole thing to run in a single pass. I mean, now could that all be done with hardware switches? Probably. But the scope of this was set initially at the OVS and DPDK and the things of that nature. So have I been thinking a bit about this in terms of testing that will be completely reusable beyond the scope a ways? Absolutely. And I think, Miriam, you would agree, right?
Yeah, I mean, it's something we've been thinking about in a lot of for a long time and in a lot of detail, and it's actually why we designed the test framework to be very pluggable. So you can plug out whatever components you want, or you could plug in new components. But in terms of the vSwitch, it's treated as an abstract object, essentially. What the underlying implementation is comes down to somebody going in and enabling a vSwitch, whether it's a hardware-based switch or a virtual switch itself. It doesn't matter to the test framework. I think the methodologies are applicable in either scenario, to be honest with you, and that's what we took into consideration when we designed the test framework itself.
Okay, I'm going to cut the mic at Ramki there.
Ramki Krishnan Del. So just wanted to add a follow-up comment on that. As a switch vendor, I can speak for and say that the hardware switches are really trailing behind when it comes to SDN type of capabilities, especially OVS, DBS schema and all that. So I think that's worth a separate capture by itself. So I think this strategy is good. We should just proceed along, not stalled by what can or cannot the hardware switches do.
Okay.
That's my thought process.
So proceed along. Okay.
Yeah, and but still, kind of, we should capture it, saying that yes, the comment is valid. The strategy should be that we should address software and hardware, but the lack of capabilities in hardware should not stall this work, is my thought process.
Good, thank you. We're running out of time here, Miriam. I'm gonna try to find oh, here we're at the summary slide. Great. So why don't you cover this quickly?
Okay, excellent. So essentially, the test specification and the test framework will continue to be in flux for some time. We'll be adding features, as I mentioned, and tests. So we would like your opinion on, you know, the adoption of this draft or this summary draft as a snapshot of the next OPNFV release called Brahmaputra. Obviously, we'll provide pointers to all of the collateral, especially as it grows and evolves, as the project grows and evolves, and eventually, you know, or have the view of eventually converting the entire test specification to an internet draft itself, and whether we should continue to provide periodic updates on the evolving test specification within this forum going forward.
Okay, well, those are good questions. Thank you, Miriam. So I would, so now speaking as chair, I would like to ask if there are, how many people in the room have read this draft? Raise your hands, please. Looks like 3, 4, and I know Scott has, so it's something like 5. So not a lot of folks in the room, but I think that what we'd like to then do is to ask on the list whether or not we would adopt this draft. And gives more people a chance to read it and to consider that possibility. And I would add that basically it's just the working group adoption of this summary, and we would point to the Brahmaputra release to freeze the summary. This eventually part would come as a completely separate proposal somewhere down the road. So it's just an idea of getting something on the table here that gives a summary. And of course, this is open source work, so you can expect that the living level test design specification is going to be improved and improved and improved. There will always be a link to that collateral, but then way down the road we'll consider what it would take to turn that into an RFC. Ramki's got a comment.
Just one thought there. Al, especially if there is something, you have a working group draft adopted, but there is an evolving framework continuously. For example, OPNFV. So we had similar situations in NFERG. Our thought process is kind of, we'll keep it adopted, but just continue like that. It may not necessarily become an RFC. That's still under discussion.
Oh, yeah. Well, actually, I mean, that's a possibility too. So let's.
Of course, it depends on how we proceed. You know,
yeah,
different
that's
strategies.
right. That's right. And I guess in general, are folks interested to hear updates on this work periodically? I see some nods. I see lots of hands now.
Totally.
So yes, lots of hands now that people have understood the question that I mumbled through. So okay, so we'll plan on continuing to do that as well, Miriam.
Okay.
And I guess. And so lastly, I really want to thank you for getting up in the middle of the night in Ireland to do this presentation. You've got the most difficult distance in terms of normal sleeping hours, so thank you.
No worries, thank you very much.
All right, so now we've got the benchmarking for control plane policing. Shishio is already up at the microphone, yes. So he's way ahead of me. All right, I got, here we go. Let's bring up this one, Shishio.
Hello, I'm a Shishio Tsuchiya. I work at Cisco Systems Japan. I'm actually a consulting systems engineer who is proposing our solution and product to the customer. And I sometimes evaluate our validation or of our proposal with the customer at our lab. And I will explain the benchmarking for the COPP. Could you move to the next slide?
Okay.
Yeah, this is explain of COPP. COPP means control plane protection, which is defined RSP 6192. The target is protect router control plane from undesirable and malicious traffic. Next page.
Okay.
This is background over this draft, and left side is a very legacy system. Service provider router connected to the CPE via the lead line, but now Ethernet everywhere. So, for example, business side, they are providing Ethernet access to the customer, and I'm not sure this is a popular service style in worldwide, but some Japanese service provider providing routerless service, which means directly connect to the switch to the service provider edge, and the client is the default gateway will be P side. And also we have a lot of we are already deployment fiber to the home in the nationwide, and in that case they have a home gateway, but speed is increasing, so sometimes the DDoS attack will be seen. And the data center, they have a lot of virtual machine, and the gateway needed large scale app or NTP, and also they have DDoS. So the customer tested this control plane COPP by themselves, MES3, and I found there is not a standard methodology. This is background over this my publishment draft. This is test setup topology, DUT connection to the router and the attack emulator and the traffic generator. Next, please.
Okay.
Yeah, this is network setup. I'm sorry, network setting. DUT configure the IGP and like a BGP between the DUT and router to get reachability in the network, and also DUT configure the COPP if needed, because some modern router configure the COPP as a default, but if needed, then the DUT configure the COPP in this point. Next, please.
Okay.
And this is the test produce procedure. Attack emulator send a packet to the DUT to confirm efficient over COPP. And the test duration time should be greater than hold time of OSPF and BGP between the DUT and routers. Next, please. This is attack packet. Yeah, it will be variable, but I defined some 9 type of attack. Like a typical is fragment attack and routing protocol, BGP, OSPF, and something like that. And this is the Ethernet-based service. Sometimes seen the undefined packet like IPX, AppleTalk, and NetBIOS, and something like that. So we can harm these attack. And I'd like to update in detail in future versions. Next, please. This is the expected test result. Attack and attack rate, and attack duration time, and loss of packet on the traffic generator. If the value in this column, then the COPP is not work expected. So, and I will update maybe we need a CPU utilization over DUT. So I will update it next future version.
One point is that
Okay.
the CPU, look at this. The CPU utilization can't be a benchmark itself. It's different for each CPU, and it's what we call a white box metric. Okay, so that's why we've noted it as an auxiliary metric in the other work that we were just talking about, the vSwitch benchmarking.
Oh.
It's something you measure alongside measuring other benchmarks.
Okay. Thank you very much.
No, good, good.
Next, please. Yeah, this is asked to the working group. Yeah, is this is the draft applicable for the working group? And yeah, as I already said, I'm a consulting systems engineer, so I'm not expert over benchmarking. So I'd like to ask you any idea over the scenario, like a test procedure. And I also configure the BGP and OSPF between the DUT and the routers to confirm the stability. But if you have any idea, then I'd like to learn from your expertise. Thank you.
Very good. Well, thank you for this presentation, Shishio, and also for preparing the internet draft. Good stuff. As I read through it quickly, I could see, that it's somewhere similar to the kinds of things we've done. A little, obviously some different protocols and some different views here. Let me ask the working group: how many people have read this draft? Looks like two have read it quickly. Scott is one of them, and he's moving to the microphone.
Scott Bradner, there ain't much to it. It's a pretty terse draft. A lot needs to be filled in before we can figure out whether it's going to be useful or not. The basic concept seems to be that, so you've got somebody who's trying to abuse your router. How hard is it to succeed, and what can? I'm not sure how the test works, in the sense of, it would seem that what you want to do is to see what the impact on normal traffic is, and I don't see that in the document.
So you're suggesting that there would be a data plane measurement in progress while the control plane's being attacked.
Something like that.
Yeah.
It's or management queries or something.
And that's exactly the approach we took, Scott, with the benchmarking of flow export, which had a diagram a lot like this. We were running a 2544 throughput test and then turning on NetFlow and seeing what the impact was. So now this is a similar thing to that. So there's actually a draft written by Jan Novak, not a draft, it's an RFC on flow export benchmarking. So that would be a good place to look to get some of the details. I mean, the very same question came up. Do I look at CPU utilization? And the answer, Jan, was no. and so it's the same thing here for you. But I think that's a good source of details that you will read about and understand a little better. Mari? Go ahead, Scott.
Just a little clarification. CPU utilization actually doesn't mean anything. Even if it was a useful value, it doesn't mean anything, because what it's meaningful is what the effect of the utilization is. So it could be 93% utilization, but it's dealing with everything. Yeah. Or it could be 2% utilization is not.
Right.
You don't really know. So by itself, CPU utilization is non-useful value.
So
other than if it's 120%, you're screwed.
Yeah, I agree.
Well, and there are some devices that seem to be reporting. I mean, I think this is the point that keeps coming up. Some devices report 100% utilization all the time, even though they're hardly doing anything. And it's just really it's a mistake in the calculation, apparently.
If you add up the idle.
Right.
Yeah, I agree.
Right, it has to add to 100% or
multi CPUs.
Yes, I agree. Yeah, I agree. Agree. Yeah. So then maybe I never update the CPU utilization, but yeah, this is a control plane polishing. So if the attack comes in, then the CPU increasing and CPU cannot control like control planned protocol like OSPF or BGP. So I think it's, yeah, DC.
Go ahead, Marius.
Marius Georgescu. I just wanted to say that this is a very interesting setup, and I think this is a very good start. I like the, as Scott was pointing out, the CPU utilization is white box, cannot really be used, but bits in, bits out, that's very interesting. The only thing that I think should be defined, and maybe this relates to Scott's initial comment, is then what's the normal, what's the expectation? How are you comparing with the well, the second scenario with the first scenario? So at first there needs to be an expectation of what was supposed to be the rate at that.
Right. So you're measuring a baseline.
Yeah, you have to have a threshold essentially.
Okay.
Yeah.
So, and then from the threshold you can calculate the impact, and then you have a benchmark. So I think that's good. Okay, thank you.
Thank you.
Good comment. All right. I think you've got some good feedback here. A few people have read this quickly, and we'll look for more commentary and further development on the list. Thank you very much, Shishio. And by the way, Shishio, would you grab the blue sheet, hold it up, and now someone in the back who hasn't signed it, please pick it up and put your name on it. Oh, well. We're kind of out of time. Why don't you put it on the list? I'm trying to move.
This is Sudhin from Juniper. I have a question on this. Do you have a measuring TTL equal to 1 packet, because that will punt to the CPU, right? That will overload that. So do you have a test methodology for doing testing that? Yeah, TTL equal to 1. TTL equal to 1. So normally that will be punting to the CPU, because that will be overloading the CPU of the router.
Yes. So that's an attack, you're saying?
No, not even attack. If sometimes fragmentation, so that will be punting to the CPU, and a lot of packets are there, special packets are there, because that the normal routing operations it will come.
Yeah.
Okay.
Yeah, I agree.
Thank you.
Yeah, I already defined other normal attack, TTD, TTLX5 and problem. And I will update some detail packet. Thank you.
Okay. Well, thank you very much again, Shishio. And so now we have Tejo, right? Tejo is going to present this draft on behalf of the authors. Tejo, you're also at Korea Telecom? Yes. Okay. So this is a draft by two of our colleagues from Korea Telecom. It's really good to have operators thinking about how we want to benchmark things, because this is, after all, the Operations and Management Directorate. So very glad to get this input. And Tejo's been, the authors were unable to attend, but Tejo's standing in for them, and he's going to present the draft today. So thank you, Tejo. This is a new draft.
Okay, good morning. I'm Teo from KT Korea Telecom, and as Walton mentioned, I'm here as that my colleague Techie couldn't make it to attend the meeting. So this draft is about some consideration for benchmarking high availability of NFVI, and it mainly deals with two part, like configuration parameter, and the other one is about test strategies. And okay, next slide, please.
Okay.
So first of all, I'd like to make some definition for high availability in benchmarking tests. So traditionally, we can define availability like in this equation, and in 4G communication, for example, for EPC, we usually define 6.9, and we thought this 6.9 should be realized also in a virtualized environment as well. And failover procedure is shown as below. It consists of failure detection, isolation, and recovery. Next slide, please. So there are some configuration parameters we considered, and there are a couple of things. First of all, with types of VNF, mean what kind of operation the VNF do, and how many CPU memory storage they need, and what kind of traffic patterns they usually face. Next one is the specification of the physical machine. I mean, for example, the network performance accelerator adoption can vary from every system. And for example, the DPDK or SR IOV technologies can be one of the configuration parameters. Next slide, please.
Okay.
The other one is mapping ratio of hardware resources to a virtual machine. So as you can see in the figure, for each physical CPU, virtual CPU allocation can differ. So it can be one-to-one mapping or one-to-multiple mapping. And the type of hypervisor and the limitation of their role means, as you know, there are various kinds of hypervisor manufactured by many vendors, and actually the kinds of hypervisor, for example, it can be para virtualization or full virtualization. They can vary in their type. And the cloud design pattern of NFVI also can be considered. Next slide, please.
Okay.
And the last one for configuration parameter is the composition of network function in VNF. I mean, one vendor's product consists of a virtual P gateway plus virtual S gateway, but the other product consists of P gateway, S gateway, and plus the mobile management entity. So we also consider this composition of network function can be one of configuration parameters. Next slide, please.
I see a lot of people putting their coats on. If somebody's willing to quietly try to mess with the temperature controls over here, you're welcome to.
Okay.
I'm sorry for the interruption, Tejo. Please proceed.
Yes, please.
Scott Bradner. I like this idea of having a considerations document. You may want to consider that in the future. Trying to fold the kinds of considerations that we've talked about some of the other things happening today into a terminology document is a poor fit sometimes. But having a document which really talks about what are we considering when we're trying to benchmark this, I think it's a useful tool. And you may want to consider that, to urge that, to have 3 documents in the base set of considerations, terminology, and then methodology.
We actually have had that on occasion.
I did a quick scan of the RFC index and didn't see considerations.
There was one
There's one that uses a different term, but it's not that.
There's a guy you may remember. It was one of the multicast address problems. It was Scott Paretsky. Scott had a considerations draft for the OPNFV data plane benchmarking. At the time, Russ White was very heavy into the control plane for IS, and Scott had to make a case to do data plane instead. So considerations came first, but then the considerations draft got folded into the other 2 in the end. So that's why you didn't find it in the RFC index. And it looks like I'm starting to remember everything now. Go ahead, Bhuvan.
Yeah. Hi, this is Bhuvan. Just a quick suggestion in the consideration side. So what I mean, it's worthwhile to consider the hardware configuration as well. Why? Because, for example, when we benchmark a VNF, same VNF on a Xeon 2.4 gigahertz processor, and when the same to be benchmarked in Xeon 3.2 gigahertz processor, so we have observed a variant behavior. So that way, it's besides capturing the physical to the virtual CPU mapping and physical to virtual memory mapping, it's worthwhile also to consider capturing all those hardware parameters as well, since that's what we have observed. And I think there is also another SDO in Etsy. I think it's also been recommended to capture, I guess. So I think that's one suggestion that you can consider.
Okay, thank you for suggestion.
Ramki Krishnan Del, I think just continuing Bhuvan's comments. So there is in fact a work happening in OpenStack called EPA, Enhanced Platform Awareness. So essentially it just brings out all the hardware capabilities. And what is interesting is talks about every, in this case, it's all about Intel x86 after all. So every Intel processor capability, nuances around QPI, bus, everything. I think we do need to bring those in. And another point which actually now we're trying to launch an open source project, it's happening slowly, is around even stretching beyond that, but kind of bring in other considerations. For example, there are subtle differences between different servers across different manufacturers and different generations. So those are additional aspects to consider. So that will make this draft, I think, complete and concrete.
Well, there's actually some overlap between the considerations that the KT authors raised and the considerations that are already in the NFV benchmarking and considerations draft that we're thinking about going to working group last call on. So there should be some referencing, I think, between these drafts as they're developed, and we'll have to pass that back on to the authors, right, Teo?
Okay.
Yeah, let them know about the existing work here. I think we need to build on each other's shoulders.
Okay.
Exactly, Albert. I think this is still focused specifically on high availability, right? Yours is a broader scope.
Right. That's right.
But you're right. I mean, the terminology should be shareable.
Yeah, very much so. Very much so. Absolutely. All right. I think I know that guy behind you. Why don't you let him up?
Stephen Wright, AT&T. I guess two comments on this. Firstly, thank you for bringing this in. I think this is a subject that's near and dear to many operators' hearts. On the magical 5 and 6 nines figure, I think there's typically some other figures that get associated with high availability, things like the scale of the failure, right? So how many subscribers are affected when there's an outage, that kind of thing. The blast radius, yeah. So there's probably some other dimensions beyond just 5 or 6 nines that need to be added to the considerations list. And I I think you probably should be careful to attach that 5 or 6 nines to something in particular, and I think that something is the end-to-end service, right? It's not a 5 or 6 nines on a piece of infrastructure or a particular VNF. So there's some mapping between the service objective of availability and the components underneath. So and that's often non-trivial.
Right. I think the essence of the comment is that some of the traditional telco figures of merit may be addressed differently in the cloud virtualized world.
Yeah. So, for example, the blast radius comment. So, a lot of the time, you think of scaling of VNFs in terms of how do you deal with capacity issues, but you may well want to keep the size of the chunks small so that you minimize the failure impact of any particular one, right? So, there's lots of ways those tools can be used. So, I think this is a good area for a considerations document. I think it will have impact into things like the design and best design patterns for VNFs and the design patterns for services. So I think this is a good direction to go. So thank you.
Yeah.
Thank you.
Very much so. I think hang on just a second. I think another reference that may help is the reliability working group at ETSI NFV produced a document that discusses many of these topics. And so the authors should take a look at that, and then we'll look at how that some of those features might be incorporated here.
Okay, I'll tell the others.
Ling Li from China Mobile. Speaking for my colleague Fu Qiao, who is not being able to attend the meeting for this time. Actually, she's leading a project named High Availability at OpenFV, and I think there is quite a bit of overlap from your draft and what we have been doing there. Actually, there have been more metrics being defined there, and we have put a lot of documents documenting the requirements for high availability and including benchmarking considerations, I think. So I'm wondering if we can, connect the two projects like Ale and Mateo has done, for VS Perf, I think. So that was my suggestion, and I think we can.
It's a great suggestion, Ling Li, and I was just trying to do that with the ETSI reliability, but you're absolutely right. HA is
we can all work together.
It's making a lot of progress.
Yes,
That's right.
It's an open source project. I think the next target will be maybe developing and testing framework for the metrics that had been defined. So
yeah, very good. Good point.
Okay,
Thanks.
thank you.
All right, nobody else is rushing to the microphone. So again, please convey. Oh, there's more here. Sorry. Do you want to cover these quickly?
Okay. So next one is we consider some test strategies, but first strategies is about single point of failure check, but it means just redundancy check. We should have some redundancy for each component of the physical machine, like VNF and the path between VNF, OVS, or virtual machines. Next slide, please.
Scott Bradner, this sounds like a functionality test, which is not within the scope of BMWG.
Right. Right.
It doesn't mean it's not important. It's just not within the scope of this working group.
That's right. That's right. We're testing a performance characteristic that can be compared between different things. And if you're just checking whether something's working or not, that's a lower level thing, different scope.
Okay. And the second one of test strategy is about failover time check, because having redundancy does not always mean high availability. So we should define the time when a failure happened. So we should have a strict definition on the start of the failure. So the candidate can be failure actually happen, or failure detected by manager or controller, or a failure event is alerted to the operator, because this part is quite crucial for operator perspective, because we provide service to customers with this sort of SLA. So this failover time should be strictly defined.
So this is a good way to make that point, that here the failover time would be the benchmark, and you'd be able to compare different systems or different strategies for the time between one or getting to the detection time as close to one as possible, and then but measuring that actual time, comparing it between different strategies, that would be a benchmark.
Yeah.
Steve?
Yeah, sorry, Stephen Wright again, AT&T. I would agree. I think you need to split this into at least two pieces, one being the detection time. And I think there's probably some other considerations around how to detect different types of things. And then there's the switchover or recovery time. So I think if I recall my numbers for Sonnet, there was like a 50 millisecond switchover time, but there was a 10 millisecond detection time. So you tend to have numbers for different things there. And
50 milliseconds was always ideal. It was always more like 100.
Yeah, once you did a hard switch, that things tend to rattle around for a while.
Right. Right.
Thank you. So this is the end of slide.
So that's it. Thank you. Well, thanks very much, Tejo. Any other final comments? Seems not. Okay, very good. Well, again, thank you for standing in for the authors and for being the lightning rod for all this commentary. And we'll try to get that captured in the minutes so we can easily feed it back to the authors for their review and further work. Again, thank you.
Thank you.
All right, Robert. Robert Szabo is going to tell us about VNF benchmark as a service, problem statement and challenges. This is a kind of a teaser presentation because Robert is going to present the entire thing tomorrow in NFVRG. So what I've told Robert is that he can have up until 11:15, and we'll cover as much as possible. And right now, of course, I'm struggling to find the deck, which is right here. Okay. All right. So let's go to view and this. And then Robert wanted to drive with my mouse. Don't worry about it, Robert. I can override you right here from the keyboard.
Hello, everyone. We just submitted this draft, and we would really like to have your guidance.
Can you get a little closer to the mic?
Yes.
In fact, just hold it.
Yes.
Yeah.
We are really seeking for your advice and guidance here, because I think this might be really relevant to the benchmarking working group. But let's see.
Yeah.
No, it's okay. Can you hear me?
Kiss the mic.
Okay. Yeah. I have to. Okay. So it's about VNF benchmarking as a service, and the contributors are colleagues from Ericsson Hungary and people from Unicam Brazil. So this is a cooperation between two organizations. This is the agenda for today. Motivation, VNF benchmarking as a service, a use case, if I will have time, and a summary. So let's talk about the motivation. So this is a kind of Etsy NFV figure, where from the bottom we can see a couple of point of presences for different technology domains, like a container data center, an enhanced hypervisor, or something like a bare metal point of presence. All of them are connected to the virtualized infrastructure managers. They are connected to NFV or VNFM for orchestration. And then maybe the interesting part to the top, we have customers who are requesting service between service access points by the means of a network service or something like a VNF forwarding graph. And we just put there VNF developers. The whole thing about this virtualization space is that we would like to have an agile approach and have third parties to introduce and develop VNFs. So at the end of the day, for the service providers, it might become an open market where VNFs can be downloaded or upgraded on demand. There are European projects, for example, Tinova, which investigates this kind of open market for VNF innovations. So what happens here is that the NFVO must pick, according to the network service, a location to host a VNF in a way that it can meet the service parameters, the KPIs required by the service, the SLA parameters. So at the end of the day, for a VNF forwarding graph, we can have associated requirements, and the goal for the NFVO is to deploy the VNF forwarding graph in a way that it satisfies those requirements. So the problem we have to solve in this kind of dynamic environment is to gain information autonomously about VNF benchmark metrics with a given resource, with given reserved resources at given virtualized infrastructure managers, which boils down to a specific point of presence. Okay. So we have the NFVO, which would like to use this information in order to decide where to place, where to deploy VNFs. But the VNFs comes continuously as an upgrade or new VNF development or replacement of an already existing ones. So this is the kind of problem that we would like to solve. Okay. So the NFVO in this case is the consumer of a benchmarking service. With the virtualization space, we end up in an environment where the infrastructure can provide a test environment as well. So we don't necessarily need specific test environments for performance tests, because the slicing and the isolation environment coming from the virtualization itself can provide means to deploy network functions without this kind of separated test environment. So the ideal is, in an ideal way, the production environment could provide means to also test and verify or benchmark or dimensions VNFs on demand. What metrics I'm talking about? The metrics I'm talking about is something like throughput, latency, and maybe jitter. And in relation to that is the resource allocation, CPU, memory, storage. I'm not interested in the CPU utilization, but if you go for a VNF deployment, you have to take a flavor of the VNF. For example, if you go for OpenStack, you have to decide how many CPUs you assign, how much memory you assign. And the thing is, you cannot scale up VNFs on demand. So it's impossible with today's technology that you just add extra CPUs. You have to stop your VNF first, and then you can add extra CPU or memory. So it's further scale out what you can do with this environment, instantiate and start many VNFs if you have to increase the performance.
Actually, I saw a Wind River demonstration where they were doing exactly that, a running VM, adding CPUs to it, adding other resources.
Yeah.
So nothing's static in this world.
Yes, definitely. It's just the current technology and the current VM-like kind of approaches. You have to take your bet on the resources to assign, and then you are bound to certain performance. And of course, as we indicated here in the figure, the different POPs might have different performance. So this is an interesting question. What are the performance characteristics related to the different deployment options, and whether you can make a selection based on that? So, yes.
Bhuvan, this is a quick clarification. All these measurements are done in the pre-deployment phase, or in the during deployment, or in the production side?
It's in the pre-deployment phase.
Pre-deployment phase.
Before deploying, yes.
Before deploying it. And one thing also I would like to suggest you to take when you look in the as a total, as a VNF deployment is, it's not only the VNF throughput, latency and jitter, and also important to note that the VNF deployment time and those characters also important to benchmark, right? So only then you will get a complete characteristics of a service performance.
Yes, yes. Okay, thank you.
All right. And one other question is, how would you measure this throughput latency? It's all through the active traffic, or through the passive way?
So we are, I will come to that. I will have
okay.
a figure on that. Yes.
Ling, China Mobile. I think this is a very interesting proposal, and I think we would love to try it. But I assume that there is an assumption here that all the VNFs under testing or benchmarking are using the same type of resources. Is that right? So it can be captured by simply CPU, memory, and storage configurations. But in reality, especially in terms of data parts, VNFs in current practice, I think they most have been utilized special hardware to do acceleration. That would mean that all the flavor that we got from the VNF vendors have already tested recommendation of combination of hardware resources as well as the virtual resource configuration. So I doubt the necessity of doing this.
That's a very good point, and the whole idea is really to come to that and to support this kind of multi-deployment environment and different hardware acceleration or different options. So the benchmarking as a service should come to that we could have a benchmarking, standard benchmarking methodology to understand and evaluate different deployment options, even with hardware acceleration or with different CPUs or different execution environments. Let me continue. Maybe we can see what I mean here. Okay. So the thing is that if you have this kind of virtualization environment provided by the NFV framework, then we can have different options. For example, the virtual benchmarking as a service can be just simply a client of the virtualization space. So me, as a client, from benchmarking point of view, can request the deployment of a benchmark evaluation, right? Because in the production environment, I would just like to have a space where I can run my device on the test, set up my benchmarking environment, and load it and measure it. Okay? So the point would be that a benchmarking service could sit as a client on top of the NFV, just like any other users, and request a topology of measurements and dedicate where the VNF should be deployed, and in that execution environment, measure throughput, latency, and jitter performance for a given allocation. As long, of course, as the measurement is repeatable, and then we have certain guarantees for the measurement setup. But basically, this is exactly the same service as this kind of network function virtualization environment would like to offer to the clients, right? Given a VNF forwarding graph, would deploy it with certain key APIs and guarantees. So if we over-dimension it, for example, the links and the measurement agents or monitors, then we can have, or we might be able to run a benchmarking test and evaluate the system under test as a black box. So that would be the point, that the VBus as a service would have a benchmarking profile, and on demand can deploy and run this kind of benchmark evaluation based on the target execution environment, and then basically the black box VNF benchmarking could be executed. Okay, so this is by the means of very similar request as we would expect from a consumer. Okay, this is just a walkthrough, which I will maybe not have enough time, but basically the idea would be that if a customer request comes to the orchestration and the orchestration doesn't know the benchmarking characteristics of VNF, which is usually stored in an information base, then it has to consult with the benchmarking service, and the benchmarking service can initiate this kind of test deployment over the production environment, okay, allocate VNFs at certain locations, POPs, and do the measurements, evaluations. And then once it can establish some basic performance benchmark characteristics of VNF, it can fill in the information base, which establish correlation between resources reserved and the VNF's basic performance, like throughput, latency, and jitter. Once done, it can send a notification back to the orchestration, and now the orchestration is position to decide where to place certain VNFs in order to meet the end-to-end service guarantees. Okay. So what are we using here? This slide reflects to the pre-deployment NFV testing initiative at the NFV. So they define benchmarking, dimensioning, and verification. Their benchmarking would be to measure the VNF throughput, latency, and jitter parameters for a given CPU memory, storage, reservation at a given virtualized infrastructure manager POP. Dimensioning would be to determine the CPU memory, storage, reservation parameters for a given target throughput, latency, and jitter parameters. And verification would be to assess if the above two could meet in a certain setup. But hey, all of these boils down to basically doing the benchmarking operations, right? We cannot do the dimensioning without doing the elementary benchmarking steps. So the dimensioning will boil down to doing some kind of benchmarks with different reservation setups and see which one meets the requirements for dimensioning. So at the end of the day, we just have to run this kind of benchmarking operations in order to do benchmarking, dimensioning, and verification. I have 2 minutes. That's it. So another project, which is Unify project, we propose a recursive orchestration framework, and then we do some evaluation related to this VNF benchmarking as a service. And there, basically, we have a setup where we have multi-level recursive orchestrations, and each of the orchestration layer, we could have this benchmarking as a service. And the point would be that either we do it as an over-the-top approach, and the external or the overlay orchestrator would deploy this kind of benchmarking as a client request, or we can delegate such kind of request to the underlying layer and ask to do the benchmarking, perform the benchmarking, and report on the results. And both of the options are possible. So in one option, we will have the benchmarking service within the same layer as the operator resides, or otherwise we can have it in the client and do it over the top or over the orchestration framework. And we have information model and a data model associated to that, where we can request and communicate such kind of VNF benchmarking results, and that's presented in the draft that's on the bottom. I will not go into that detail, but there's a netconf operation model described how to request and report such kind of benchmarking results.
So we've got 2 minutes. Let's take a minute or two for a question here,
Yeah.
and then wrap it up.
Okay, so Stephen Wright, AT&T again. So thanks for this. Look forward to more details. I think absolutely we need this kind of thing. The concern I have is that we probably need to scale this up in terms of the types of tests and the types of benchmarks that need to be considered. You've got to start somewhere, and what you've got is fine, but it occurs to me that for a lot of different types of VNFs, throughput, etc., may not be the appropriate metric. So if it's a so if your VNF is a HSS, then like transactions into the database might be more relevant, right? So that's one thing. And second, I think a lot of the if the functionality that you're trying to benchmark is the scaling ability of a VNF, then you're getting multiple extra test heads that you need to instantiate. So again, there's more complicated testing arrangements that may be needed to support this, but you got to start somewhere, and what you've got makes perfect sense. Thanks.
Well said. All throughout this, I was thinking, what about more than one VNF at a time? This is a very often a shared environment. Yeah, Ramke, it's got to be really quick.
Yeah,
thanks.
So real quick, I think we're also doing another related work in NFERG called VNF performance modeling. So I think that's right on answering some of Stephen Wright's and Al's concerns. So
right,
just wanted to add.
Good.
I fully agree with those comments. Thank you.
Very good, Robert. Thanks so much. So now we've entered the sort of the celebratory part of our agenda here. We're celebrating the fact that we've been at this for more than 25 years, and the reason we've been at it is because of Scott Bradner. Scott founded this working group, and I've tried to assemble every working group chair that's ever been part of this to say something here today, and others who are responsible for keeping the community alive. So without further ado, let's see if we can get Kevin DeBray online. Kevin invited me to become part of this fraternity or sorority or group of chairs, since we've crossed the all sorts of lines here. And are you out there, Kevin?
I'm here, Al.
Oh, that's great. So I've got your first slide up. Please tell me when to go ahead.
Will do. I first came to know Scott as a participant at his network device test lab at Harvard about 24 years ago, when he subjected perfectly innocent routers to his own little brand of discomfort, if you will. So when Al wrote me and asked if I would say some words considering Scott and his milestones, I knew I would have a challenge. I think the daunting part in considering Scott is how to frame him. So if you go to the next slide, Al.
Yep.
Part of the problem is that over his tenure with us, Scott's worn a lot of different hats and have a lot of acronym alphabet soups associated with his name. So the real challenge is, well, which one of these dimensions do you try to talk to? And it's really kind of difficult because Scott's a very diversified type of guy. So one of the things that I thought of when I cogitate over some of these areas here is, well, Scott's pretty successful, so he must be able to marshal time pretty well. So with that, you can go to the next slide, Al.
Okay, I'm there.
All right. I said, how about considering Scott as a master of time management, right? If you search the web, you'll find a whole variety of different properties associated to guys and gals that have good time management. Well, when you wear the hats that Scott wear, you have to have great time management. So it seemed to me Scott, through all his BMWG associations, has mastered all these areas. So it might be a good context to frame the discussion. Next slide, Al.
All right.
All right. So So when we look at vision, well, it's clear Scott has definitely helped lay the foundation for what our vision is as a working group, right? What you see there is really the description of part of the charter when it came to be around. Correct me if I'm wrong, Scott. IETF 15 back in the fall of '89. The BMWG, though that its charter has been expanded over time, it remains directionally and consistently the same. And I think a lot of that speaks to Scott's shepherding of where the group wants to be and where it needs to be. You know, an interesting side effect to, you know, the vision that Scott helped us achieve is the notion not just that we're coming up with benchmarks, you know, not just tests, but a way to assess fairly and to provide insight to folks. A side effect to all of that is to raise the bar for networking technology. Next slide, Al.
I'm there.
All right. So if clear vision is one attribute of someone who's manages their time well, delegation is another key attribute. And Scott really embodies this, right? Scott has enabled lots and lots of people. Some would say conscripted lots and lots of people to contribute to our effort here. But as Jim McQuaid, my predecessor as BMWG co-chair, mentioned as we were discussing it on Monday, Scott was always there to guide us and to foster us, to keep the needle moving forward to where the community needed us to be. That's a key enabler in terms of delegation. It's not enough to decide, delegate, and disappear. It is really to empower and enable. And I think, you know, Scott really personifies that. I think the success shows that since its founding, our working group has produced over 34 RFCs, and judging by the progress tonight, there's a lot more on the way. Let's go to the next slide, Al, if you will.
Okay.
So if delegation and vision are attributes, so too is embracing efficiency. To be a master of time management, efficiency, whether it be using tools, process, or straightforward communication, is critical. I think this is one of my favorite examples of efficiency in communications, and I think you know, it came about when people asked to redefine the notion of zero loss throughput, and Scott gave you know, a two-lettered response. I don't think you get much more efficient than that. No wonder he has, you know, he's able to context switch between a lot of different tasks. Let's go on to the next slide, Al.
Okay.
All right. So another critical element when you're trying to manage time well is to know where to place your focus. And it really, what you want to do is you want to put focus where it matters the most. There's a lot of things in time management that, you know, it's important or it's urgent, but it doesn't really move the needle towards the big picture. And so Scott has had that ability from the time the working group was founded till today. He understood really what makes a meaningful benchmark and who we're writing these benchmarks for. All right, it's not just a test that you can execute. It's a test that yields insight. It's a test that is a basis of comparison. All right, and I think Scott has always been a shepherd and a watchdog, if you will, to make sure that indeed this team here tries to keep our focus to things that is useful to our community. All right. I think also as we look at certain things, we want to take a look at what are some of the side effects here, right? Because we talk about the big picture. It's not just benchmarks, although that's what we're tasked for. one of the things that we might not be tasked for is to come up with explicit good put citations, right? What is goodness in terms of throughput? Scott has stayed away from that, although with smart architecting and suggesting of benchmarks, it kind of moved folks to what goodness might best look like, right? When we talk about zero loss throughput, you know, in the early days, not a lot of router vendors could claim that, but they kept pushing the needle and pushing the needle. And even though there's nothing that says, you know, throughput must be zero, and we don't recommend that, right? The notion is vendors move themselves, so they had the right catalyst here. So I think that's an important level of contribution that Scott has kind of steered us to in some of these things, helping us realize that how do we collect some of these benchmarks and supporting the tester instrument community and independent test labs are equally important. So again, the notion here, not benchmarks as an end to themselves, but a way to make our network community stronger and better. And I think that's really an important thing that Scott has done through his tenure with us. So the last slide, Al.
Okay.
So if putting all these things together are the recipe for good time management, knowing when to escape is another key element of that. And you know, in closing, you know, I really would like to thank Scott on the behalf of ghosts of BMWG participants past for his contributions to our working group and the results, whether they be directed or side effects that we have enjoyed over time. So thanks.
Thank you, Kevin. I appreciate that tremendously. And one's old email comes back to haunt one.
Indeed.
And I wish I'd seen that one. Jim McQuaid, are you out there? It seems not. How about Sarah? I think, Sarah, do you have audio?
I do, Al. Are you able to hear me?
Yes, we can hear you. So if you have a few words you'd like to say to Scott as one of the many, one of the few or many BMWG chairs, please do now.
Yeah, you know, that last presentation with slides is a hard mark to follow. And I'll also note it's one of the few that Joel actually wrote the entire name of the benchmark. So I think there is joy in writing benchmarking time management and the soft science of the side effect. Good job. That's a hard act to follow. And Scott, you're a hard act to follow. I think through my time, not only in BMWG, but at IETF as a whole, he hit the nail on the head. You've had influence throughout our entire organization. BMWG clearly wouldn't be BMWG without you. It was surprising to hear you're going to retire. I suppose we're all going to retire at some point, but it was kind of shocking as the new chair on the block, I guess, to maybe not see your face at one of the upcoming meetings next year. So I find I'm missing you already, and although I'm not there this meeting, and I hear maybe you'll be at the next, your mark is indelible. And we are definitely better for it. So thank you very much for your contribution to our little working group.
And, well, so Jim, we'll give you one last chance.
I don't see him.
You don't see him? Okay. All right. Well, Scott, would you please come up? I have a little something for you. I'm going to use Robert's trick of doing this with a remote control. Yeah. So, Ronky, I'm going to give my camera to you. Sure. So you can take a picture so while we're doing this. So I hope. Let's get in the box.
Oh, the box. Big box, we're getting assassinated.
So So let me advance the slide. So Scott, I thought that you've probably got, look, he's quick to get it there too. I thought you've probably got plenty of plaques. You've got letters of appreciation. You've got all sorts of things from people. And when I thought about doing this, I said to myself, well, what could we give you that would fit someplace other than your walls, and that you might see once in a while and think of us fondly. And so it's a tiny lab bench, a workbench inscribed with the BMWG recognizes Scott Bradner, founding chairman, 1990 to 1993. Let's just get that out of the way. How about that? Oh, okay. and so founding chairman, and in our hearts and minds forever. That's the most important part.
Well, thank you very much. I appreciate all of the sentiments expressed here. I don't expect to completely go away. I'll be on the mailing list. I actually just resubscribed with my non-Harvard email address a few minutes ago. So keep up the good work. It's been very important to me, this working group. It was the first thing I did at the IETF. And I suspect it'll, at some level, be the last, because it'll keep going for a long time. So thank you very much.
Thank you. All right. Well, that's a hard act to follow, so we're just going to stop now. Thanks, everybody, for attending. This was a really productive session, and look forward to seeing you in Buenos Aires.
Yeah.
A little fragile.